superoxide free radical. Now this is new, completely new. First off, that term radical refers to a molecule of some sort with an extra electron, with one more electron than it's supposed to have, or maybe one less. Either way, but it's got an extra electron. Notice the minus sign here. So it's basically O2, the way it's supposed to be, with an extra electron. That's the radical, having that extra unpaired electron. Now the reason these are super dangerous is because that extra electron is very, very, very unstable. It wants to pair up. It doesn't like being single. It wants to be paired. So O2, the radical, is going to bounce around inside our bodies and other organisms and will essentially steal electrons from other molecules. So in stealing the electron, that electron will be paired. Got two of them. So then it's happy. Unfortunately, the molecule where it stole the electron from now becomes a radical. So the free radical, this is true for all the radicals. The radical, in stealing an electron to pair up its electron, thereby creates another radical. Because now it's missing an electron. So that radical will start looking around for another electron. Basically, it's a pinball effect. You've got all these radicals bouncing around, stealing electrons from other molecules, other tissues, and you're creating radicals all over the place. That's tissue damage. So it's not good. Formed in small amounts, just in normal, everyday activities, respiration or glycolysis. Again, extremely reactive, as I just told you, and they're toxic. Over a period of time, yes, it will break us down. Well, we are protected. We are protected. Superoxide dismutase. Notice the ASE, that means enzyme. Superoxide dismutase. It is an enzyme, it neutralizes the radicals. Coming. This is how. Here's your equation. Radical plus protons, 2 protons. So the enzyme superoxide dismutase takes all that and produces H2O2 plus oxygen. H2O2, did anybody know what that is? I mean, not from me, but from somewhere else. Hydrogen peroxide. That's hydrogen peroxide. I don't know if you knew it or not, but hydrogen peroxide. Okay, so on the one hand, we got rid of the radicals, but this creates problems all over the place. First off, we made oxygen. That's how we got into this mess, is by having oxygen. Now we have more of it. Not good. We're trying to avoid that. But actually, the bigger problem is the peroxide. This would be a little bit difficult to explain. I'll do my best with it, but it's not real simple. Okay, most of you have had chemistry before. You know that the ion for oxygen is a -2 ion. Oxygen makes a -2 charge. So we have 2 oxygens, that'd be a -4 charge. We have 2 hydrogens, hydrogen is always a +1. So your total charge would be a -4 and +2, be a -2 charge. But, well, you just add up the charges. The problem is they don't add up. Because if there were a charge here on the molecule, it would say so, it has to. See here, it says a -1 charge, a -1 charge, a +1 charge. It's got to tell you if there's a charge. Here, it's not telling you. What that means is there is no charge. It's a 0 charge. Now what that means is, go ahead.
Use the -2, but in this case.
I know. So there's something wrong here. The wrong is oxygen's supposed to be a -2, but this time it's not. It can't be, because it won't work. So in fact, the only way to make it work is hydrogen will be a +1, that can't change. Oxygen has to be a -1. It's the only way it's gonna work. So oxygen would be a -1 times 2, so a -2 total. The hydrogens are a +2 total. So the -2 to the +2, that gives you the 0 charge. So hydrogen peroxide is a molecule where oxygen has a -1 charge. It's not supposed to do that, but it is doing it. And furthermore, it's a perfectly stable molecule. Like I told you the other day, you can buy that stuff for 39 cents in the drugstore. So there's a lot of it around. So, but that's a problem because it's a weird molecule. Nature does not like weird molecules. We don't want that in our system. Again, weird molecule.
So on this one,
The enzyme.
is the enzyme?
The enzyme. Dismutase is the ASE. Dismutase is the enzyme. So it's taking these three, putting them together to form these two. That's the enzyme.
How
So-
is that any better?
It's not. Glad you asked. It's not better. We got rid of the radicals, and that is good. But we clearly have made another problem. So is it better? Yeah, not really. Not really. Bear with me. So this is what I kind of told you earlier. The radicals will steal other electrons from other molecules, making other radicals. Ending up with tissue damage all over the place. Okay, so is it better? No. So I think it's rebelling against it. I better make it a fast lecture. So, what do we do with the peroxide? Okay, peroxide contains peroxide anion. So there's the anion. Remember, anion is a negative ion. So take off the hydrogens. What you have left is O2 with a -2 charge. Because again, the two hydrogens are a +2. So that pretty much shows you, yeah, each oxygen has to be a -1. You know, it's not supposed to do that, but it does do it. So it's also toxic. This is found or used in antimicrobial agents. And again, we have that in our bloodstream. So again, not very good. I mean, it's a strong ion and it causes damage and all that stuff. We don't want the radicals there. We don't want the peroxide there. The dismutase actually will get rid of the radicals. To get rid of the peroxide anion, we have another enzyme, catalase. This is what we used the other day. This catalase will neutralize peroxide. Here's the formula. 2 hydrogen peroxides, and then the enzyme will be here, and catalase will give you 2 waters and oxygen molecule. So once again, we're making oxygen. It's still better than having the peroxide, but still having oxygen there is not that good either. The water, of course, is fine. So there is another possibility. There's another enzyme yet. Peroxidase. Peroxidase does not produce oxygen. Here's the formula. Peroxide plus 2 protons simply gives 2 waters. No oxygen. Now there's an obvious question here, and that obvious question is, why 2 enzymes? And how do you know which one to use? Well, how do you know which one kind of varies? But why 2 enzymes? It's kind of a compromise. Notice the catalase reaction. You're taking 2 peroxides, breaking them down to form water, but you're getting oxygen. The peroxidase reaction, you're only breaking down 1 peroxide, but no water, or no oxygen. So the compromise is, if you've got lots of peroxide, then use catalase to break it down faster, 2 at a time, even though you're getting oxygen out. If you don't have that much peroxide, then use the peroxidase. There you're only breaking down one at a time, so it's half as fast, but no oxygen. Like I say, it's a compromise. Catalase will be faster because it's breaking down two at a time, even though there's a side effect, oxygen. Peroxidase is slower, only producing one peroxide. I'm sorry, breaking down one peroxide, but no oxygen. You're looking at shirt.
Remind me of that O2 charge.
I'm sorry.
Remind me of the charges on that O2 up top.
Oh, here's nothing. You mean the other
The
slide?
other one, just right there. I just wanted to know.
No, here there's no charge. I mean, O2 is just O2. That's just neutral. In fact, all elements are neutral. All elements are automatically neutral. And O2 would be an element. But what we had before, see, that's not neutral. So that's not an element. This would be your anion with a -2 charge.
Is that neutral up there as well?
Got to tell you. Like I was saying, oxygen, this is the tricky part of the whole thing. So you'll kind of learn the reactions, know the enzymes. There is one more of these, one more. Fortunately, it's an easy one. Hydroxyl group, our old friend. There should be a minus charge there. I didn't put it in, I forgot. But there should be a minus charge. It's got the extra electron. Hydroxyl free radical. And it's actually the most reactive of all of these. The reason it's the most reactive is because it's small. Small is quick. So these guys can fly all over the place, stealing electrons. Radiation forms it in the cytoplasm. You might think, well, big deal. We don't live near a power plant. Yeah, we kind of do. It's called the sun. The sun, believe it or not, the sun's radiation, yeah, a lot of this is light, visible light. But the sun produces other radiation that does go through our tissues. It goes right through us. And it's called gamma rays. At any rate, so it forms it in the cytoplasm. So we all have this. Unless you don't go out in the sun for your whole life. So we all have it. So anyhow, so we also find hydroxyl groups formed in the dismutase reaction. Changing the superoxide free radical into peroxide. That's the dismutase reaction. The fact is, we all have hydroxyl groups. In fact, we all have all four of these. But as you see, we do have protection. That's why we don't just keel over. But over a period of decades, as we get older, it takes a toll. It adds up. Kind of odd that we obviously require oxygen, but then, it's also killing us too. You can buy these antioxidants in the stores, and I guess they help, but I have several friends who take antioxidants. And all I know is they seem to be getting old as fast as I am, so I don't know if it does any good or not. I kind of think it does. Okay, what else do I have? Okay, so obligate anaerobes. Now, frankly, this statement is not entirely correct. They don't have dismutase or catalase. This really refers to the obligate anaerobes that get poisoned by oxygen. So for some obligate anaerobes, the oxygen is actually a poison and it kills them. So that would be the case if they don't have the protective enzymes. But some bacteria do. We have aerotolerant bacteria. Aerotolerant bacteria. These guys are obligate anaerobes. They're not using oxygen. But as you can see, they can tolerate it. These guys would be extremely similar to us with nitrogen. We don't use the nitrogen, but it doesn't bother us one bit. But these guys, they don't use the oxygen, but it doesn't bother them one bit. They just don't use it. So presumably, these guys do have dismutase and catalase. That would be the assumption. again, that is the tricky part. Everything else is okay. Any questions?